All right, I'm going to go over some notes. We're going to start going into our ratios and proportions unit. So I'm going to give you some introductory ratio notes. One thing that you have to understand that anytime you see a fraction, that tells you to divide. It's also a ratio to some point. So as we do this, from here on out, you're going to see me do divisions mostly as a fraction, because that's what a fraction tells you. It's the top is the numerator divided by the denominator. So you should have a copy of your slides. You're going to fill in the blanks as we go. You're going to do some work near the end. It's not going to kill you. This again is just an introduction to our ratios. All righty. So we have the situation where, first of all, a ratio is a comparison of two quantities by division, written in the form A colon B, or A to B, or A over B as a fraction. Again, that's because it's a comparison by division. So we have these three scenarios here. We have the Charlotte Hornets have a winning record, 3 wins to 6 losses. So that's one way we can show a ratio. Again, that we're using the word to. For the same situation, we have the Charlotte Hornets record is 1 to 2. That's using the fraction format. And then we have the Charlotte Hornets have a record of 3 to 6, using the colon. That colon replaces the word to. It has the same implications as the fraction and the word to. So those are ratios. We can also write ratios in the simplest form. You noticed in the second example of the Charlotte Hornets, I put that as 1 to 2, or 1/2, which is a simplified fraction. So when we have the ratio 24 to 18, we can simplify that to 4 to 3 using the colons. We can also use the words 4 to 3, or of course the simplified fraction, 4 over 3, or 4/3. Now remember, you guys can pause and take as much time as you need on these. I'm going to move on. All right. Within ratios, we have another situation, which is called a rate. A rate is a ratio that compares two quantities in different units. We see this all the time. When you go to the store and you want to buy some drinks, it's going to be so much money per ounce, or so much money per 12 pack of sodas, or you get a dozen eggs for so much money. Those are all rates because it's two different quantities or units of units. For example, the one that you hear all the time and that you can't wait to start doing is to do with driving is your 75 miles in 3 hours. That's a rate. You went 75 miles in 3 hours. We can rewrite that as 75 miles to or over 3 hours. Or we could do that 75 miles colon 3 hours. Either's fine. But you'll generally see those as a fraction. Kilometers per hour, you'll see in most countries. When we start dealing with physics, it's going to be distance over time. So meters per second. There's just another example of how you're going to see these ratios and rates specifically play in a lot of things we do in real life. You make so much money per hour. That's the big one that you really need to pay attention to. That is the rate of money you earn for the work you do. Now, we can take that unit rate, and we can even make it further defined as a unit rate. So we start off with a ratio, the comparison of two quantities by division. We define that a little more. and we call it a rate, in which that's a ratio that compares two quantities in different units. So now we've added our units to that. And then a unit rate is where we measure is a rate that has the second unit measured to 1. For example, milk, $2.77 per gallon. Generally written as a number, unit per unit. Most of the time when you're dealing with money, your money is always going to be the top value, or the numerator part of the fraction. The denominator is always going to be whatever you're comparing that to. Unit rates or ratios simplified to the format of A over 1, where A is whatever our main thing is. For example, money is how we see it the most. Miles per hour, per 1 hour. With units by dividing the top by the bottom value. So if we look at our 75 miles per hour, or 75 miles in 3 hours, we can make that into a unit rate. 75 divided by 3, we know is 25, so that would be we were traveling at 25 miles per hour. So here we have another example. We drove 125 miles in 5 hours. We divide 125 by 5, and we end up with 25 miles per hour. Not very good traveling speed, unless you're running. You know, that's pretty good speed if you're a runner. So that's how we find our unit rate. Leave that. And moving along, when we have different ratios and they have the same value or the same comparison, we call those equivalent ratios. Ratios that name the same comparison. They doesn't necessarily mean that they completely equal, but they are equivalent. For example, 10 over 6 is equivalent to 25 over 15. We can simply simplify those to their smallest units and find that. If we divide 2 out of the first one, we have 3 over 2. If we divide 5 over 3. If we divide the 5 out of the second part, we have 5 over 3. So we can see that those are equivalent. So let's take a look. 2/7 and 6 over 21. 6 to 21. Are they equivalent? Yes, because if we simplified 6 over 21, we divide the 3 out from both the top and the bottom, we will end up with 2/7. So yes, those are equivalent ratios. Now, when we have ratios that are equivalent, an equation, and we can set them up in an equation, we now have a proportion. So a proportion is an equation stating that two ratios are equivalent. If the ratios are equivalent, they are said to be proportional to each other or in proportion. So if you look at the 10 over 6 and 25 over 15, it is a proportion because they are equivalent to each other. That means that as the one value changes, the bottom value changes exactly the same in both of them. So we know that those are equivalent, and they are also considered to be proportional to each other. All right, so here we have some practice. Yes, this is where you're going to have to create some text boxes and put some numbers in and some work. So here's some prime examples of how we can find ratios and rates. If we're going to use this table, we want to find out what the ratio of red and blue t-shirts is to the green t-shirts. we can start doing some annotations here. Anytime you see the word and within a ratio problem, so red and blue, that means that we are going to add those two values together. So we know that the red and blue t-shirt should be one value. When you see the word 2, we can say that that is our fraction, that or our that is also considered to, you know, our fraction, our colon. So we can set that up as a fraction. I just did the same thing, didn't I? Colon or fraction. So now we're going to simply find our values. So if we go in and we look at our red shirts, that's going to be 24. I know this is horrible. I'm using a mouse. Plus, now our blue shirts, 42. And then we're going to simply put our 2 and our green shirts, which is 36. So now we're going to add those values. 24 plus 42 gives us 66 to 36. I could have said 66 and used the colon. I could have used the words 2. So I'll give you all your examples, possibilities. Colon 36. I just prefer the fractions because that's the way you're going to see it most often. If this was an EOG test question where you had to actually bubble in, you would have to put it as a fraction. And then, of course, the other is 66, the word 2, 36. We could also simplify that, and it would be perfectly fine. So if we divide 6, that would be 11 to 6 is the same ratio. All of these are the same, telling us we have this many of red and blue t-shirts to this many green t-shirts. All right. Purple t-shirts to yellow t-shirts. So purple 2, so that's going to be our fraction bar. Then put my fraction bar there. Yellow, there's my and, tells me that's a plus sign. All right, so purple 51 to my yellow 60 plus, and my green 36. And I will end up with, get this in here, 51 to 96. Perfectly fine answer. You can write it with the colons, you can write it with the word 2, you can even simplify this down. It does simplify. I'm not going to do that because it's not necessary. All right. So next one, blue and green t-shirts. So here's my word and, which means plus. Here's my 2, so there's my fraction. Purple means plus, and red. So our blue t-shirts is 42. I'm going to type this. So we have 42 blue t-shirts plus 36 green t-shirts to our purple plus red. 42 and 36 is going to give us a whole big 475. Just checking, make sure you're paying attention. All right, so we end up with 58 to 75. And we have one last one on this page. I'm not going to do this one for you. You get to do this one. So you need to put your answer and show your work right there. All right, that's where you're going to do your work for this page. Okay, next set of examples. These are really going to make your brain hurt. I'm telling you that they're so hard. All it says is write 3 different ways. We're not wanting to find different values or equivalent ratios. This is simply wanting you to write the ratios in 3 different ways. So we have 7 in the word to 21. If you look at these examples, you can see that what they're wanting. So if we write this, we can say 7 colon 21. That's one way we can write that. Remember our different variations. And the other way that we can write a ratio is as a fraction in the form of a to b. So 7 over 21. I know this was so hard for you guys. I'm telling you. It's gonna make these brains melt. Guess what? It's your turn to do these because this is pretty simple stuff. I mean, seriously, guys. So here's your answers. You need to put your answers in right in here. Now, 8, 9, and 10. The first one wanted you to write them in 3 different ways. This one wants you to write equivalent fractions. There's 2 ways you can go about this. You can simplify them down if they do that, or you can simply multiply multiples. So if I take this 19 over 38, make this a little smaller so it'll fit. So I have 19 over 38, because that's what that's saying, 19 to 38. And I want to write equivalent ratios. If I multiply both my top and my bottom, let's say I multiply this by 2. I do it to the top, I got to do it to the bottom so I don't change the value of that situation. Then I'm going to get an equivalent fraction. So 19 times 2 is our wonderful 38. 38 times 2, we get 16, carry the 1, 76. So there's one. I can also divide. So if I simplified that, 19 is a prime number, but 19 does go into 38, as we can see. bear with me. I'll make it pretty here in just a minute. So we know that 19, oops, made a mistake there. So 19 times 1 gives us our 19. And 19 times 2 is 38. So here's another equivalent fraction. So 1 times 19 gives me 19, 2 times 19 gives me 38. Multiply by 2 to get this fraction. I can multiply this fraction by 2. I can multiply this fraction again by 3. I can even multiply this fraction by 5 and still have equivalent ratios. So this is how you would do this. So number 9, 5 and 3 are prime. So we're not going to have, we can't make that any smaller. We cannot simplify that any further. But we can multiply these numbers. So if I multiplied that 5 to 3 by 2, I would get 10 over 6. If I multiplied 10 over 6 by 2, I will get 20 over 12, and so on and so forth. So that leaves you with your problem. Do this one. That's your answer. You got to give me number 10, your work. All right, number 11, word problems. This is how you're going to see these more than likely. A 12-ounce bag of birdseed costs $3.12. A 16-ounce bag of birdseed costs $3.84. Which is the better deal? How much money per ounce would you save by buying that size bag? So this is an example of unit rate. This is a unit rate problem. And it's real simple the way to solve it. We're going to put our money over our ounces. And we're going to divide to get it to a 1 ounce rate. So we have $3.12 divided by, keep my units on there, divided by 12 ounces. And if I put that in my handy dandy calculator machine, so 3.12 divided by 12, you end up with 0.26. That's 26 cents per ounce. So here we have $3.12 for 12-ounce bag. Simplify that into a unit rate by dividing the top number by the bottom number, just like the fraction says. And we end up with our rate of 26 cents. Now, we have our other one, which is 16 ounce, $3.84. We're going to do the same thing. We're going to do $3.84 divided by 16 ounce. We're going to put that into our fancy calculating machine. So 3.84 divided by 16, and you get 0.24 cents per ounce. So now we've calculated which one is cheaper. We found out that the 16-ounce bag is cheaper because it only costs 24 cents per ounce. Oh boy, and we're still not done. How much money per ounce would you save by buying that size bag? So we are going to save 2 cents per ounce. All I did was I subtracted the difference. So 2 cents. You ready for this, guys? I know you're ready to do some work. So number 12. There are 60 players on a high school football team. The ratio of juniors and seniors to freshmen and sophomores on the team is 23. The ratio of juniors to seniors, oh, I don't even have the whole problem. Guess what? Don't worry about it. And that is the end of our notes. Again, where you see I added these red boxes is where I need to see your work. I also need to see the notes that I gave you. So I'm going to leave these. I need to see all this. Your grade is based on accuracy and completion. Keep that in mind. So till then, I will see you online.